Okay, here we go. Key stage 4 waves topic. And lots of keywords that then go along with this unit. The maximum displacement of a wave from an undisturbed equilibrium. Okay, so there's your wave. Amplitude is that distance there. The angle of incidence, the angle between the incident ray and the normal. Okay, so there's your normal, should be a straight line. That there is your angle of incidence. The angle between the reflected ray and the normal, so that angle there is then your angle of reflection. An object will appear this color if it absorbs all wavelengths of light. Okay, so red, orange, yellow, green, blue, indigo, violet. If it absorbs them all, it will look black. Filters that absorb certain wavelengths and transmit others. A blue filter, for example, will absorb all wavelengths other than those in the blue region of the color spectrum. So blue absorbs everything except for blue. Color filter. A lens that brings parallel rays to focus at the principal focus. The image formed can either be virtual or real. Okay, so a lens is that shape, convex. A technique that used high frequency sound waves to detect objects deep in the water, to measure the depth of the water. Some people call it sonar, right? This is then echo sounding. Transverse waves that transfer energy from a source of waves to an absorber. They form a continuous spectrum of different frequencies and all travel at the same speed in a vacuum. Okay, so what you can do is you can start off with radio, which has very long wavelengths, and it gets shorter to gamma at the end. Electromagnetic waves. The distance between the center of a lens and the principal focus. So when the light comes in, I'm just showing this diagram here now. When light comes in, when it shines in, the lens focuses it. That is then the focal length. The number of waves passing a point in a second is its frequency. The unit of frequency is hertz, Hz. Human hearing can hear sounds in the frequency range of 20 Hz to 20 kHz. A type of radiation that all objects emit and absorb. The hotter an object, the greater the radiation it emits in a given time. Infrared. Used for cooking, electrical heaters and certain imaging. Infrared. Radiation that can cause mutation of genes and cause cancer. X-rays and gamma rays. Ionizing radiation. An object that forms an image through the refraction of light. Okay, so we talked about it before. You could have convex and you could also have concave. They are lenses. A wave with oscillations that are parallel to the direction. So this time the wave looks a bit like that. So they're supposed to be the same length. Longitudinal wave. The ratio of an image height over the object height for a lens and has no units. Okay, so the equation for that is your microscope one. AIM is magnification. Used for satellite communication and for cooking food. Microwaves. This is the imagery reference line that is constructed at a right angle to a boundary at the point where the wave intercepts it. Okay, so what I did was then that is supposed to be a mirror. Okay, draw mirror lines. Light comes in, that's supposed to hit there, sorry about that, and it's supposed to come off there. The line that comes off at 90 degrees is the normal. The time it takes for one complete wave to pass a given point, it is the inverse of frequency, so it's 1 over f. Okay, it's on your equation sheet, is a period. A measure of the risk of harm to the body as a result of radiation exposure, radiation dose. Okay, so that's a measure of how much you've got. Used for television and radio signals that can be produced by oscillations in electrical currents, radio waves. Okay, remember your electromagnetic spectrum. It starts off radio, it's got long wavelengths, and it gets to X-rays and gamma at the end there. They've got very short wavelengths. This is when a wave bounces off a boundary. The angle of the incidence always equals the angle of reflection. Okay, I've drawn this a few times already. Okay, so there it is. Angle of reflection when it bounces off is the angle of incidence. That is reflection. Longitudinal waves responsible for sound. In solids, these waves are transmitted by vibrations of the solid's particles, and in a gas and a liquid, they are then transmitted by the particles in the gas and the liquid, but they travel a lot faster in solids. sound waves. Waves with oscillations that are perpendicular to the direction of travel. Okay, so there is your transverse wave. A technique that involves waves being transmitted and then partially reflected at a boundary before being detected is ultrasound, used for mostly looking at babies. Used in energy efficient lamps and for sun tanning, ultraviolet, which is again part of the electromagnetic spectrum. The only type of electromagnetic wave radiation that our eyes can detect is used for fiber optics, visible light. Richard of York gave battle in vain. Roy G. Biv, red, orange, yellow, green, blue, indigo, violet. The speed at which energy is transferred through a medium, wave speed. The distance from a point on one wave to the same point on the adjacent wave. Okay, so have a look at this diagram here. From there to there is a wavelength. From there to there is a wavelength. From there to there is a wavelength. An object will appear this color if it emits all wavelengths equally, white. Okay, good load of words in there. All right, take a look at electromagnetic spectrum. Okay, so then you kind of need to know the order of it as well, from radio all the way through to gamma. Blank piece of paper, write down the key words. Okay, brilliant. Right, now, if you got them all right, fantastic. Right, if you didn't, have a look at the ones you got wrong, and now do it again on your next page in your exercise book. Okay, right, job done. Right, again, don't forget, go over it again in not too distant a future, a month or two. Okay, well done.